Hello and welcome to Soft Papers channel. My name is Mr. Godfrey M. I am an experienced teacher with Cambridge International Curricula. In this video, I will be solving a science paper from Cambridge Primary. It is paper 1 of April 2019. If you have not already subscribed to my channel, please click the subscribe button below and hit the bell icon. This way you will be notified every time I upload a video on solved papers. I wish we get started. Question number 1. Complete the sentences of human senses. Complete the sentences on human senses. 1 has been done for you. Of course, we have 5 human senses. You know that. Therefore, those are the ones that you're going to be answering this question on. The first one that's been done for us is I feel with my, the answer is skin. I hear with my, of course, we hear with our ears. I see with my eyes, of course. I smell with my nose. And I taste with my tongue. I taste with my tongue. Question number 2. Question number 2. Ice melts into liquid water. The melting of ice is a reversible process. Explain why. Of course, we all know the 3 states of matter. The 3 states of matter are the 3 states of matter. The 3 states of matter are solid, liquid, solid, liquid, and gas. And we know that we can reverse any one of this. So question number A of number 2, the melting of ice is a reversible process. Explain. We know that when ice melts, we get water. Therefore, we can also get water to freeze. Water can be frozen back to ice. Water can freeze back to ice. So that is why this reaction is a reversible reaction. Question part B. Complete the sentence. The sentences. The melting point of ice is, of course, 0 degrees, and the boiling point of water is 100 degrees, assuming that the water we talk about here is pure water. Question number 3. Air resistance is a force. It slows down moving objects. Of course, it opposes motion. Skaters want to move fast. You can see we have 3 skaters there. Their helmets are smooth to reduce air resistance. Skaters reduce air resistance by wearing smooth helmets, which you can see right over there. Write down 2 other ways. 2 other ways skaters reduce their air resistance. Number 1 way the skaters reduce air resistance by streamline. Of course, the way they are bending right there is to form a streamline shape. This will have less air resistance. Okay. The other second way skaters reduce air resistance is by crouching. You can see they are kind of bent. That is what we call crown shade down. Crown shade down. So two ways to reduce air resistance: by forming a streamline shape. That's why you can see their hands are held behind, and then of course they are kind of bent. That is to crouch down to reduce air resistance. Let's go to question number 4. Here is an outline of a human. We have area A, B, C, and D. Of course, these are human. You can see the shape. That is part A, which organ has a position in area B? Circle the correct answer. Of course, brain is in area A. Intestines are in area C, I suppose. Liver as well could be either area C or D. Stomach is of course in area C, and therefore the lung is the one that is in area B. Area B is the correct answer there. Part B, which organ has a position in area D? Which organ has a position in area D? You can see area D is right there. Area D is right there. So which organ has got a position in area D? Okay. In area D, the organ that is, of course, the brains is not there. The liver, the lung. Area D, the organ is intestines. Intestines go all the way to the abdomen. So that is the answer right there. Part C, in which area would you find the earth? Circle the correct answer. Which area will you find the earth? If I can take you back to the areas. Which area will you find the earth? Of course, the earth should be around area B here. The earth should be around that area right there. So then, of course, the answer here should be area B. The answer here should be area B. Question number 5. Yuri hits the tuning fork. Yuri hits the tuning fork. Tuning fork makes sound. To make a sound, he puts the tuning fork on water. The tuning fork is right there, and then this is of course water in a trough. Explain why there is. Explain why there is a pattern on water. Of course, the tuning fork is vibrating. Of course, to make sound, objects needs to vibrate. To make sound, the objects or the tuning fork is vibrating. So tuning fork vibrates to make sound. Vibrates to make sound. Okay, so the pattern you're seeing on the surface of water here is due to the vibrations of the tuning fork. So in this case, our explanation should state that the tuning fork vibrates. This makes the water to vibrate as well. This makes the water to vibrate. And of course, the water will vibrate in the same vibrations that the tuning fork is vibrating. And of course, the vibration in water then will send the sound through water. Send the sound through water. Question number 6. Question number 6. Question sound number 6 is right here. Humans and elephants have only bony skeletons. Okay. You can see the elephant has got a trunk. It's got an elephant skeleton, just same as the human, right there. Our question is, the trunk of the elephant does not have any bony skeleton. Explain why. Explain why. Explain why the trunk of the elephant does not have a bony skeleton. Does not have a bony skeleton. Explain why. Of course, the trunk of the elephant requires it to be flexible, and therefore, if it has bones, then it will not be flexible. So, in this case, we are saying that it needs to be flexible. That is, the bony, the trunk needs to be flexible. Okay, and of course, there are purposes for that. One, that it can pick up food. Without food, the elephant will not die, and will die, of course. And secondly, there is also no organs. There's no organs inside the trunk, and therefore doesn't need to protect that. Remember, the skeleton needs to be a protective mechanism for organs inside our body. So it doesn't need a skeleton because it does not have to protect any organ inside the trunk. So those are the reasons why the trunk of an elephant does not need to have a bony skeleton. Of course, it needs to be flexible so that it can pick up food and also water. And of course, there's no organ inside the trunk to protect. Number 7. Chen collects information about recycling in different schools, and seemingly has plotted a graph here. Mass of material recycled in kilogram on the y-axis. Then we have school A, school B, C, D, and school E. The question here is part A of 7. Write down the mass of material recycled by school B. The mass of materials recycled by school B. Of course, you need to look at the bar graph of school B, and then you'll notice that the bar graph of school B is at 7. So the mass of material recycled by school B is 7 kilogram. Part B. School D recycled 1 kilogram, less than school A. School B recycles 1 kilogram, less than school A. Draw a bar for school B on the bar chart. Right? We need to draw that for school D. So to draw that, we have to identify school A. How much did they recycle? School A recycled 6 kilograms, and therefore school D will recycle 1 less, and 1 less should be at 5. Will be at 5 there. So school B will recycle at 5. So this is 5. Of course, you draw a bar chart at 5 at school D. At 5. Right there. So this is the recycle of school D at 5 kilogram. Part C. Part C. Chen makes a conclusion. He says school C recycles the most. I think this is because school C is the biggest school with the most children. Suggest one other reason why school C recycles the most. And as you can see from the graph, school C actually recycled the most. School C recycles 10 kilograms of the material. And therefore, Chen is saying the reason why school C is being able to recycle that much is because he thinks school C is the biggest school with the most children. And we are told, suggest one other reason why school C suggests one other reason why school C recycles the most. The other reason I suppose could be C has the most recycling facilities. Basically, that means that it has got the most. It is more suited for recycling, of course, than the other schools' facilities. This doesn't mean that it is the biggest school. That could be a possibility, but also the other schools could also be bigger than school C. But C has got the most facilities that can handle the material, or children in C know the importance. Children in C know the importance of recycling. That could also be another reason why C is recycling the most. Number 8. The table below shows some properties of 6 materials. Right there. We have material A all the way to material F, 6 of them. And each material is given the hardness. You're given the hardness of each material, the melting point, solubility in water, and strength, weak or strong, 1 to 10. Part A of question 8, material E has a low melting point. Okay, what is the meaning of the word? What is the meaning of the words melting point? Of course, melting point is the temperature. We know this is the temperature at which a solid turns into a liquid. When heated. Okay, so that is what it means by a melting point. Numbers, part B. A cutting tool needs to be very hard, and have a high melting point and be very strong. Which material is best for a cutting tool? 3 things: very hard, it's a high melting point, and it is very strong. So we need to circle the correct answer. To do that, we go to our table. Go to our table here. So very hard, we have D is very hard. You can see the hardness of D is 10. Of course, you're given the key here. 1 means it's soft and 10 means it's hard. The melting point of D as well is 10, the highest, together with A, B, and of course, yeah, A and B. And then, of course, the strength of D is also very high, very strong. It's got a strength of 10, together with C. So if you tick the hard, melty, and strength, you'll find that D, we have ticked all the boxes. Of course, B, which has got a high melting point of 10, it is not hard. It is at this hardness is at 4, and of course the strength is at 1. So that cannot be the answer. So the answer here is D. So we circle the correct answer, and the correct answer for us here is D. Question number 9. Sophia is investigating seed germination. She has 4 dishes. She adds some seed to each of the dish. Look at the dishes in the picture. We have dish A, B, C, and D, the 4 dishes right there. In dish A, there's water and light. So seeds have light and water. In dish B, there is water, but it is in the dark cupboard, so there is no light. C has got light, has no water, and D, it is in the cupboard, so no light and no water. What is the question here? The question is A, in which dish will she find germinated seed after 2 days? Circle the correct answer. Of course, germination requires light and water. So the only dish that has got, of course, requires water, not so much as in light. Of course, it will require light when it has grown for purpose of photosynthesis. So we only have water in dish A and dish B, and therefore the germination will occur in dish A and dish B right there. So we cycle dish A and dish B. Part B. What else do seeds need to germinate? For germination, seeds will not require light, but will require correct warmth, or what we call the correct temperature. So for germination, the seed will require correct temperature. Or what we refer to as warmth. Of course, they don't require light, because of course light is for purpose of photosynthesis when they have developed leaves. Question number 10. Bless's head makes a shadow on a screen. Okay. You can see Bless's head is there, and the screen is right here. Of course, there is a shadow of Bless's head, which is right there. Part A, complete the sentence to explain why there is a shadow on the screen. A shadow is meant because Bless's head, of course, for a shadow to be meant, an object must block the light. So Bless's head blocks the light. Bless's head makes a shadow because it is made of dash material. Of course, transparent materials do not block light. It's only opaque materials block the light. So Bless's head is opaque. That's why it has blocked the light. Part B, Blessy moves towards the light source. What happens to the size? What happens to the size of the shadow of Blessy's head? Of course, as you move closer to this, Blessy moves closer to the light, her head will block more light. And therefore, this means that the shadow gets bigger. The shadow gets bigger. If you move away from the light source, of course, you block less light, therefore the shadow will be smaller. Question number 11. Seawater contains many substances dissolved in it, of course, in the water. One of these substances is salt, right? Look at the chart describing how clean drinking water is made from seawater. We have the seawater here. We have process A. Process A produces steam and salt and other solids. Then, of course, process B, we get clean drinking water. So, what is the name of process A? To produce steam from water, of course, water is in liquid form and steam is in gaseous form. Okay, so it's a gas. So of course, to get from liquid to gas, of course, we need to supply heat. We need to heat. So the name of process A is boiling. That is done by heating. We have heated the water to the boiling point, and therefore now it changes to steam. Part B. What is the name of process B? What is the name of process B? Process B, we are finding that we are moving from gas to liquid. Clean drinking water is a liquid. Therefore, to move from gas to liquid state, we perform cooling. Now, when we cool our steam to liquid to get water, we call that process condensation. We call that process condensing. So it is condensation, condensing. Part C. Part C The question is, seawater cannot be filtered. Seawater cannot be filtered to remove salt to make clean drinking water. Explain why. Now, the reason, of course, why we cannot filter, we can only filter when we have a mixture of liquid and a suspension of solid. So if you will use a filter paper, then of course the solid will remain. But here, the salt has dissolved in water, and therefore, because of that, because it is not in solid form in water, the salt cannot be filtered. So it is because the salt is in the solution, dissolved in water, is in solution, dissolved in water, so it cannot be filtered off. Before we tackle question 12, I'd like to point it to you that it's great you're watching this video, but remember practice. Remember, practice makes perfect. Practice makes perfect. So I encourage you to practice working out these questions yourself. I need you to practice working these questions by yourself, and you can get this same paper I am solving right now in this website, solved papers, all lowercase, solvedpapers.co.uk /checkpoint. Of course, I need you to go to the primary tab, and you may ask your parents, you may ask your dad or your mom to help with this. Of course, to make this happen, to get these papers so that you may learn to practice on the questions. The more you practice writing the question down for yourself, the easier for you to be able to remember in an examination situation. So back to question 12. We are told that Carlos draws a food chain. Carlos draws a food chain, and you can see the food chain here. We are told that the food chain is wrong. Okay, the food chain is wrong. We can see we have an impala here, we have grass, locust, scorpion, we have a baboon, and we have a leopard. We are told, of course, we are told that food chain is wrong. We are told to circle the part of the food chain that is wrong. The part of the food chain that is wrong, and the part of the food chain that is wrong is this part here. Grass do not feed on impala. Impala feeds on grass. So grass, part B, we are told that the grass is a producer. Explain what it means. Grass is a producer. Now, a producer is that object that makes its own food, does not depend on others for food. So grass, it makes its own food. Grass makes its own food. That's why it is referred to as a producer. Part C. Explain why a baboon is a predator. Explain why a baboon is a predator. Of course, a baboon is a predator because it chases food. It chases food. Of course, it gets its food by hunting. of course. So if it is hunting, then it's going to prey on other, it is going to prey on other species, like in this case, it's going to prey on the scorpion. Therefore, it is a predator in that sense. Question number 13. Jamila learns about the Earth and the Moon, of course, in the solar system. Then she draws a picture, as you can see here. The sun rises in the east, sun in the morning, it's rising. Of course, it's overhead at midday. And of course, the sun is going to set at the west. We are told to describe what the picture shows about the Earth and the sun. Of course, you can see the sun is in different positions in different times. In the morning, the noonday, and of course in the evening here. So we are just taught to describe, look at the picture and write what you see in the picture. So I can see one, sun is at different sun is at different positions at different times of the day, at different times of the day, different times of the day. Okay. Of course, you can see the sun is rising in the morning and is setting at in the evening. So sun rises in the morning. That's another thing that you can observe from the picture right there. Of course, it is also overhead at noonday. Part B, Jamila says that the sun is not moving. Jamila is of the opinion that the sun is not moving. The sun appears to move. Okay. Jamila is of the opinion the sun is not moving, but the sun is in different position during the day. Okay. Explain why the sun appears to move. Right. Of course, we know that the sun doesn't move, but the Earth is the one which is spinning. And therefore, when the Earth spins about its axis, then since we are on the Earth, we observe the sun in different positions, and therefore it appears to us as if the sun is moving, and actually it is not moving. Let's look at question 14. Look at the diagram of a fizzy drink. Diagram of a fizzy drinks container. Of course, you would look at this as your favorite Coca-Cola canned drink. Of course, inside we have carbon dioxide. Of course, container is made of aluminium, and inside we have water, sugar, and flavoring. That, of course, gives you the taste of your lovely soda that you love. Part A, which material shown in the diagram is gas? Which material? We have carbon dioxide, we have aluminium, and these others materials. So the only material which is gas here is the carbon dioxide. Carbon dioxide is the gas that we breathe out when we inhaling. We take in oxygen and we breathe out carbon dioxide. So carbon dioxide is a gas. Okay. Part B. Part B. Aluminium is used to make the fizzy drinks container, right? Because of its properties. One of these properties that it does not corrode, otherwise it will contaminate our fizzy drinks. Write down 2 other properties of aluminium, why it is used to make this fizzy drink container. Remember, we need to consume these fizzy drinks. We need to consume soda. So then aluminium therefore must be non-toxic. Aluminium must be non-toxic. You write it correctly. Aluminium must be non-toxic. Non-toxic means that it is not poisonous. Secondly, aluminium should not be reactive, should not react with water, because you can see water there. Should be unreactive. If it reacts with water, then that will be disastrous. And also, can also add a third point here. Aluminium should not be able to dissolve in water. So insoluble. Aluminium should be insoluble, because you can see we have water right there. So these are some of the other properties that make aluminium to be used to make these containers. Otherwise, you cannot use a material that is corrosive or that can corrode, like iron or steel. You don't use those. Question number 15. Safia is investigative forces. Safia investigates forces. She puts a book on 4 eggshells. Eggshells. You can see we have got some 4 books. 1, 2, 3, 4. And they are placed on 4 eggshells. Safia earns books until the eggshells break. She records the number of books needed to break the eggshells. She repeats the investigation. Each time she uses new eggshells. Here are her results. Okay, she has gotten her results right here. So Safia has done the investigation, around 5 investigations, and she's noticing that the number of books range from 5 to 2, right? This is repeating. So the question here is, Safia thinks, part A, Safia thinks one of our investigation is not correct. Which investigation does she think is not correct? Explain. And when you look at Safia's data, of course, the books that are required to break the eggs range from 655. So the investigation that seems not to be correct is investigation number 4. So 4 is not correct, because only 2 books are breaking the shell eggs, and we are assuming that she's using the same books all over in the investigations. So what is the explanation here? Right? The explanation is that we only have 2 books, so you can put it away. The number of books in investigation 4 is lower. The number of books is lower. The number of books in investigation 4 is lower, and therefore that gives Safia to kind of suspect there's something that she did not do right. Part B, Safia's investigation is not a fair test. Okay? Describe why it is not a fair test. Right? Of course, it's not a fair test. 1, because she uses different eggshells. Okay? So if it was to be a fair test, she would use the same eggshells over in each one of the investigation. But you realize that the eggshells are getting broken, so she needs to use different eggshells, and therefore that makes the investigation not to be a fair test. All right. So she uses different eggshells, and can also say that the books, as you can see up there in the photograph, the books are of different sizes. The books are of different sizes. Sizes. If she needs to make it a fair test, then these books, you see here, these books should be of the same size. These books should be of the same size. Question number 16. Mia investigates electrical conductors. She's investigating electrical conductors. Okay. Sorry. Mia investigates electrical conductors. Right here. She puts different materials in the electrical circuits. Right. Of course, she has an electrical circuit made of the lamp, a cell, and of course the material she's testing. Right. She's investigating. Of course, we need a lamp so that we may be sure when the current is flowing. When the current is flowing, the bulb will light. The part A, the symbol for the cell is this. Draw the symbol for the lamp. Of course, the symbol for the lamp should be something like a circle. Okay, and two lines crossing inside, making an X. And then, of course, you show the connected circuits. That is the symbol for a lamp. Okay. Part B. Some materials are good conductors of electricity. Some materials are good conductors of electricity. What happens to the lamp if the material is a good conductor of electricity? Of course, the lamp will light up. The lamp lights up. That's when we know the current is flowing. And when the current is flowing, then we should be sure the material that is under investigation is a conductor of electricity. Okay. Part C. Which material is a good conductor of electricity? Good conductor of electricity. You need to circle the correct answer here. And of course, all metals are good conductors of electricity, so that's what you're looking for. So paper is not a metal, plastic is not a metal, rubber is not a metal, wood is not a metal, silver is a metal. So silver is the only good conductor of electricity among that group. Question number 17. Yuri investigates evaporation of water. Evaporation of water. Water turns from liquid to gaseous state. Yuri, in his first experiment, Yuri does a few things. Puts 50 centimeters cubed of water into a glass beaker, puts the glass beaker onto an oven for 24 hours, measures the volume of water left in the beaker. Yuri does this experiment at different temperatures. Yuri predicts as the temperature of the oven increases, the volume of water left in the beaker decreases. Here are Yuri's results. Complete the table. Okay, we have to complete this table for Yuri. We have the temperature in degrees Celsius. Temperature increases from 30 to 70. We have the volume of water, of course, in the beaker in centimeters cubed. The units in centimeters cubed. Volume of the beaker of water left in the beaker in centimeters cubed. Of course, and the volume that evaporated. So the volume that evaporated is equals to the initial volume in the beaker minus the volume that is left. So for the first case, we'll take 50, take away 45 that is left in the beaker. Therefore, the volume of the water that evaporated was 5 centimeters cubed. So that's what we write here, 5 centimeters cubed. For the next one, it is 50 minus 40. This will give us 10. So we write 10 over there. The next one, the next row is 50. The initial volume of water is always 50 to make it a fair test. So the water that evaporated at 50 degrees Celsius was 20. And of course, when the temperature was 60, the water that was left in the beaker, was 10 centimeters cubed. So the water that evaporated was 40, right? And at 70, Urey did not find any water at all left. Therefore, it means that all the water evaporated. So at 70 degrees Celsius, 50 centimeters cubed of water evaporated. Part B. Do the results support Urey's prediction? What did Urey predict? Urey had predicted that as the temperature of the oven increased, the volume of water left in the beaker decreased. Of course, you can see the volume left in the beaker is decreasing. So Urey's prediction is correct. So do the results support Urey's prediction? The answer is a sounding yes. A resounding yes. Use the results from the table to explain your answer. Of course, you can see as the temperature increases from 30 to 70, as the temperature increases, we are using the results of the from the table to explain this. So you have to state some results in the table. So as the temperature increases from 30, you can see it's from 30 degrees Celsius, to let's say 60. Of course, when you say to 70, of course at 70 there's no water left. To 60 degrees Celsius, less water is left. Less water is left in the beaker. And therefore, Urey's prediction is correct. As we continue to question number 18, I would like to let you know that I do online classes. I teach students from all over the world in online class. I have an online class at this website, Spacey Academy, spacademy.co.uk. I welcome you to join me. You can just get to SP Academy and register or sign in and join me for my own online classes. I guarantee you will discover a great opportunity of getting outstanding grades. So looking forward to see you in my academy. Let's continue with question number 18. Mia has two plants. She removes all the leaves from one of the plants. She gives both plants water. She gives both plants light. She puts both plants in the same class for 5 days. Mia draws the results. Of course, you can see Mia's plants there. Okay. Mia draws the results. Okay, this is Mia's drawing for plant A and plant B. Okay, you can see plant B does not have any leaves. Plant B has no leaves. Describe one other difference between plant A and plant B. Describe. Description is just what you see. You don't explain anything. You just describe. And of course, I can see that plant B, B is smaller. Plant B is smaller than plant A. That is one difference. I can also see that, of course, we also taught this. Plant B has no leaves, therefore has no flowers. You can see plant A has got flowers there and leaves. Plant B, which does not have leaves, has no flowers. So that's a difference between plant A and B. Those are two differences. You can write more if you can see more differences. Part B, why does the plant need leaves? Of course, we know that plants make their food in the leaves through the process we call photosynthesis. Therefore, without leaves, the plant will not make food, and therefore it will be to have a malnutrition, so that it doesn't have sufficient food. So plants needs leaves to make food. So to make food, plant needs to take in light for photosynthesis. In the process of making food, photosynthesis to occur so that it makes food, to occur and make food. So plants need leaves. Without leaves, it will not be able to make food. Let's look at question 19. People in an island make lots of rubbish. The rubbish contains food waste, glass, metals, paper, and plastic. Hey, the people on the island must remove all of this rubbish. Write down one problem that happens if the rubbish is not removed. Of course, we know that rubbish causes littering. And littering is usually eyesore, and of course littering will takes up space and attracts rats and insects. This will attract rats and insects, and we don't want that to happen. We don't want insects around us. We don't want rats around us. Rats will carry some diseases. We don't want that to be transmitted to us due to rubbish. So we need to clear up the rubbish. Part B. One way to remove rubbish is to use recycling. Explain how a magnet can be used to remove some metals from rubbish. Of course, we know that some metals can be attracted by a magnet, or they are magnetic. Some metals are magnetic. Not all metals are magnetic. We are saying some metals are magnetic, so they will be attracted by a magnet. So they will be attracted. They will be attracted to the magnet, and in that way they will be removed from the rest of the trash or rubbish. Part C, some of the rubbish is burnt, right, like papers and plastics, which is not a good idea. This makes smoke and gases. Suggest how burning rubbish can be a negative effect on the environment. 1. Smoke will be pollution. Of course, also burning will also produce carbon dioxide, which is also an air pollution. So burning will cause air pollution. You will not breathe nicely when they smoke, of course. And of course, some of the products of burning will be gases that can cause global warming, like carbon dioxide gases, that can cause global warming. So those are some of the negative effects of environment. Of course, global warming will cause adverse weather effects like floods and also prolonged drought. Question number 20. The table shows properties of some substances. We have 5 substances here: chalk, copper sulfate, gasoline, iron sulfate, magnesium sulfate. And of course, their states at room temperature, their color, and whether they are soluble or not in water. Part A, which substances are insoluble in water? We can see chalk is not soluble in water, and gasoline. Both are not soluble. Soluble means they will not dissolve in water. So the substances that are not soluble, we call them insoluble. Therefore, that happens to be chalk in these substances, and gasoline. Gasoline is petrol. Of course, petrol is like paraffin. It floats on water. Part B. Rajiv mixes gasoline and water. Suggest what he will see. Because gasoline will float on water. So gasoline will be on top of water. Gasoline will float. Floating on top of water. That is what Rajiv will see, on top of water, because they will not mix. They are not miscible liquids, and therefore it will float right there.